So the topic of today's video is properties of parallelograms. Our objectives are I can use the properties of parallelograms to identify them and to distinguish them from other quadrilaterals, and I can state and use the 5 ways to prove that a quadrilateral is a parallelogram. So we'll start off. The first property: if a quadrilateral is a parallelogram, then both pairs of opposite sides are congruent. So if we have quadrilateral A, B, C, D, then our pairs of opposite sides are congruent. So AB is congruent to CD, and BC is congruent to AD. Second property: if a quadrilateral is a parallelogram, then both pairs of its opposite angles are congruent. So if we have parallelogram EF, GH, then our opposite angles, so angle E is congruent to angle G, and the other pair, angle F and angle H, are congruent. Our third property: if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. If we remember back, supplementary angles means they add up to 180 degrees. So again, if we have parallelogram A, B, C, D, then if our consecutive angles means one after another, so angle A and angle B could add up to 180, angle B and angle C will add up to 180, angle C and angle D add up to 180, and angle A and angle D add up to 180 degrees. Our fourth property: if a quadrilateral is a parallelogram, then one pair of opposite sides are congruent and parallel. So again, if we have parallelogram or quadrilateral ABC, D, then one pair of opposite sides, so if we say BC is congruent to AD, then BC is also parallel to AD. And our fifth property: if a quadrilateral is a parallelogram, then its diagonals bisect each other. So again, if we have quadrilateral WX, Y, Z, then the two diagonals here, so YW and XZ, bisect each other. So that means if they call this point V here at the middle, then YV is congruent to VW, and XV is congruent to VZ. That's the definition of bisecting, as we saw last unit. So, an example: the following figure is a parallelogram. We want to find the value of x and y. So our first property says that opposite sides are congruent. So we can say that x is equal to 9, and then y equals 15. Another example: if we say this figure L, M, and P is a parallelogram, and we want to find the measure of angles N, L, and P. So if we start out with angle P, because that is an opposite angle with M, we know opposite angles in a parallelogram are congruent, so angle P is 95 degrees. And if then we go to angle L, we know consecutive angles are supplementary, so we can subtract 95 from 180, and that will give us angle L equals 85 degrees. And angle N we can solve multiple different ways. We could use opposite angles with L, consecutive angles with M or P, but let's just use the opposite angles are congruent. So if angle L is 85 degrees, angle N also has to be 85 degrees. So there are 5 ways that we can use to prove a quadrilateral is a parallelogram. And they are: show both pairs of opposite sides are parallel, show both pairs of opposite sides are congruent, show both pairs of opposite angles are congruent, or you can show just one pair of opposite sides are both congruent and parallel. And the last way, we can show that the diagonals bisect each other. Well, one more example. If we want this figure, call it ABCD, to be a parallelogram, then we need to show that these two segments are congruent, because diagonals of parallelograms bisect each other. So we need, if we call this point E, we need DE to be equal to BE. So for that to happen, we set both of these equal to each other and solve for x. So if we add 6 to both sides, we get 4x plus 8 equals 5x. Then subtract 4x from both sides, and we will get that x equals 8. So for this shape to be a parallelogram, x has to equal 8. Alright, now our review. Properties of parallelogram: both pairs of opposite sides are congruent, both pairs of opposite angles are congruent, consecutive angles are supplementary, one pair of opposite sides are congruent and parallel, and the diagonals bisect each other. Make sure you go online, do your reflection, get those bonus points for the section, and we'll see you tomorrow.